until 25 past.
Perfect. Cool. So I think we're live. Hi everyone. Welcome. I hope you're enjoying the conference. This is a panel discussion. We're going to be talking about data on Kubernetes, so stateful workloads, managing data, both persistent and data in flight. So I'm joined by Christian and Ron. I will let them introduce themselves in just a second. But firstly, I'll say hi. I'm Ed Shee. I work at a company called Selden. And what we do is we do machine learning deployments on Kubernetes. So I'm coming at this from the kind of handling data science workloads, and particularly things unique to machine learning, and running all of that on Kubernetes. So if I pass to Christian, do you want to say hi and introduce yourself and your company?
Yeah, hello, my name is Christian Klein. I'm from Elasticys, a cloud-native startup in northern Sweden. And what we are doing is that we are building Kubernetes-based platform for those customers that need to stay on European jurisdiction. And part of our platform, we not only offer running containers, but also databases, message queues, and in-memory loaded cache. So I have quite a lot to say about data on Kubernetes, and especially pitfalls to take into account before you do that in production.
Awesome, thanks, Christian. And Ron?
Hi, Ron Eakins. I'm a principal architect at Pure Storage. I work in the office of the CTO, advising customers about their data management challenges. So last year, Pure Storage bought Portworx, who is the leader of sort of software-defined storage for containers. So happy to be part of this panel.
Cool. Well, yeah, thank you. And then, so what we'll do is we'll dig into some topics, but this is much more fun for all of us, right? If this is a bit more interactive. So if you throw things in the Q&A or into the chat, and I'll keep an eye on that as well, because we, rather than us rambling about things for a while, it'd be better if you guys could steer the conversation and tell us what you want to hear. So yeah, just to get us kicked off, I was going to start with the kind of general sentiment around running data workloads and stateful applications on Kubernetes, right? Because I think definitely if you asked everyone this, I don't know, 3-4 years ago, they'd say absolutely no way, right? Kubernetes is stateless, microservices only, but it seems to be shifting. I don't know if Ron or Christian, if either of you want to weigh in on that and see what you've seen over the last few years.
I can weigh in on that. So we have been running databases in production for our customers. And initially we did it like it was a trend half a decade ago to just do it on top of VMs. And of course you fall into various pitfalls, like, well, you need to have a primary, you need to have a secondary, you need to have some kind of failover mechanism, you need to connect them. There's a lot of manual work and wiring to be done, right? Of course, there is software that facilitates that, but that's often not open source, and it often comes up with some heavy licenses. But so we had to kind of do it by ourselves. And then I think we were among the first companies when I heard around us where we said like, okay, we're Kubernetes experts. Surely we master that stack well enough to be confident about also running database on top of that. And we noticed that we weren't alone. It was approximately the time where Zalando released their Postgres operator. So we said, okay, let's try it out. Let's see how this is going. In the meantime, Kubernetes has also evolved, and they had added better support for stateful sets. Extending the Kubernetes API via custom resource definitions has also matured significantly since then. I think container storage interfaces and the implementation of them has matured also significantly. And at the end of the day, people are now a lot more comfortable. And when I tell people nowadays we run database inside Kubernetes, yeah, okay, no news there. But when we made this choice the first time, it was quite controversial, both internally and externally.
Yeah, Christian, I agree with lots of the points you raised there. I think the tipping point was the support by the storage vendors when they're CSI drivers. Exposing persistent storage to easily to containers has made it the same experience as other platforms. So we can take storage snapshots, we can do cloning, we can dynamically create volumes, all from our Kubernetes environment rather than having to speak to a storage administrator or pre-provision them. We can do it dynamically, and even more, a lot of agility in the cloud for that as well with Cloud Drive. So, moving from stateless to stateful has been enabled by the CSI. it's interesting seeing that. I mean, I've been working with data for 30 years, and I'm an Oracle Waste director, so I speak a lot at Oracle conferences and see how it's the traction in the open source and in the commercial database space, and where there's a reluctance to adopt it because people in the container world are saying it's not for you, database people. These are stateless. It's for smaller microservice solutions. It's ones that only are around for an hour or two, not for databases which are there for 6 months, a year, multiple years. Database life cycles are very different to your classic container. Heavy I/O, lots of memory. It's not normally a good fit, but once you start embracing the database operators, it becomes a lot easier to manage, and it's definitely something I'm seeing more and more. People, once they've adopted it, they love it. There's a study earlier this year that said the majority of people that have migrated to a database in containers, they prefer to run it in containers. They find that it's a lot easier to manage. It gives them the ability to move between on-premise and the cloud, a lot of agility. And a common way of working, whatever the environment. So there's a lot of benefits for database professionals.
Yeah, I was reading some stats on that as well, and it looks now like I think it's over 50% of organizations now run databases on their Kubernetes clusters as well, which in this particular survey I found, which was I think as we said, it's come a huge way from when I first started working with Kubernetes was back. I was actually at IBM at the time, and we were, one of the cool things, right, was we were the first cloud to adopt Kubernetes, right, and have a Kubernetes offering, which of course at the time was really cool. We could shout about it, but people were like, "What? Kuba? What?" And they hadn't really heard of it. And then very quickly all the other clouds adopted it, and it became a standard. But it very much our policy then was like, tell people, as you said, Ron, this is for stateless microservices. You containerize your app, you deploy it. But the great thing about Kubernetes is that if it dies, it'll just spin it back up again. And that's why it's a lovely stateless microservice. And as you said, I think the tools, the interfaces, the Kubernetes APIs itself have all come a long way and made it much easier. Because back then I was advising people would say, people say, oh well, if I have to just run stateless microservices, what do I do with my data? And I go, well, you either keep running it the way you're doing it, or you just pay a database as a service, right? And have someone else do that problem because it's too difficult. And I think that rhetoric still exists, but it's going away.
Yeah, I mean, when we look at operators and what is the purpose of an operator, it is a really good fit for databases. The operator manages placement, it manages state, it keeps things up. And that's what you want with a database. You want it up. If it fails, you want it to start somewhere else. It handles a lot of the networking and storage side of it, and the services, all things that databases need. So, you only run a server for a purpose, and normally that purpose is related to data. So, whether that be transactional data or historic data or machine learning, ultimately, it's everything we do is data-driven.
I'm also wondering if it's also not a matter of people having gotten a bit more comfortable with Kubernetes and storage, because in a grand scheme of things, if you think about it, well, we were used to the idea of attaching virtual disks to virtual machines for quite a while. And then Kubernetes storage classes are essentially doing the same thing, right? They're attaching a virtual disk to some kind of VM and then exposing it to the pod. And then maybe it took a bit of a while to realize people, well, you don't have to have the whole container dying. Its data can outlive the container. And then people got more comfortable with this idea. And that has perhaps also made it a bit easier mentally just to adopt the idea of having data on top of Kubernetes.
Yeah, I think what we see in the data space is data professionals are always a bit more cautious than maybe other people in the data center, because their job is to protect the data, is to have integrity and resilience around that data. So they need to be convinced that the platform is secure before they move their data to it. What we've seen, if we go back 15 years, it took a long time before VMware was considered to be the platform for applications and databases. We had to be convinced that it's a virtualize. Now, people would argue, why wouldn't you put it on a virtual platform? So I think it probably took 10 years, that journey. I think the container journey is going to be a lot less. It's I think within 2 more years, it will be the standard for many database deployments.
Yeah, and to be honest, that risk aversion, at least to me, makes perfect sense, because let's say that Kubernetes is not in the beginning, when Kubernetes was not a mature technology, people were saying like, well, no problem, just nuke from orbit, as the expression goes, and redeploy, right? It's stateless. You can just recreate it from your code. Whereas with databases, recreating the state or restoring from backup is a very tedious and time-consuming operation. And then if you need to do it while downtime is happening, then it's super stressful. So then people need a bit more convincing to understand that, yes, this is the right solution for something. So that kind of risk aversion goes very well with the choices that we have seen in the past.
I think it's also the size of the data sets. Yeah, when you have multi-terabyte databases, it takes a long time to restore that data. It takes a long time to replicate it across different cloud providers. You don't want to be destroying and recreating on the fly too often. It takes a long time to populate the database. It might take only a few minutes to start the container, but if you have to do a data load, come back next week.
Yeah, exactly.
Yeah, and also, the data is almost it's definitely the most important part as well, right? In application, as you said, you can spin them back up, but there's also very little in your application code that really is like the intellectual property of your company. But the data is so important. Like, if that falls over, you could be looking at wiping huge chunk off your stock value if you're a large company, and things like that. Whereas an app going down, it hits you, but not nearly as badly.
I think that's the next challenge for us to understand and to get a consensus of the best approach. I mean, in the database and application world, we've considered security, and we build our platforms to be secure from day one. I don't think the same mindset's still there in the containers world. Databases and storage. In a database, we would probably think about encrypting our databases. Encryption at rest would be the norm. Maybe data encryption as well. Encrypted database connections. And I think that's still to come. It's still probably early days in the Kubernetes space.
Do you think that maybe so we talked about how partly the adoption has grown because it's become a lot easier. You can install the operators now. It handles a lot of the work for you. Is there a danger in that people, with great power comes great responsibility, right? Anyone can spin up Postgres on a kube cluster now, but do they actually know what containers it's putting down? What's the base image of Postgres running? Does it have vulnerabilities in it? Probably most people who are running that don't know, right? And I think you're right. That's the containerized workload mentality is, well, I can run it and ship it fast. And if I can do that for a database too, even better. But yeah, there's probably a trade-off for security on that.
Yeah, front. I think there was a report issued this week, and it reckoned there was several 100,000 database endpoints open on the internet. Yeah, where people have spun up containers and they haven't thought about locking it down. It's the same as S3 buckets on AWS. The controls are there, but if you're not using it correctly, if you don't say it's private or public, if you don't have a bastion hosting your cloud infrastructure, or you're not securing it correctly, somebody else would be knocking on the front door of your database and trying to come in and take your data.
That really shows what I tried to tell so often to people. Like, these operators, they really save you time doing, but they don't save you time learning. I mean, not only do you need to understand the database system, but now you also need to understand the automation that the operator does for you. So it feels a little bit like, okay, you need to first know how to drive the car, and then you're being taught how to activate cruise control. I have never went to driving school where they teach you like, oh, let me first activate cruise control for you and then figure out how to steer, right? Yeah. And that in a way adds complexity, right? Because now you need to understand two systems and not just one. So that makes it so much more important to understand these things. Okay, who talks to what? How do I secure this system? How do I make sure that I'm in a good disaster recovery posture? How is business continuity really working correctly? Do I have the right number of replicas and so on? And yeah, it shows what you were just saying. Like, it's so easy to spin up a Postgres instance. It's so much more difficult to make sure that it has the security and the stability that you require.
Yeah. Okay. So let me play devil's advocate for a minute here. Then, given even with operators and Helm charts and things and so on, making things easy. If you still require that knowledge in order to be able to efficiently run it, and definitely securely run, let's say, a database on Kubernetes, that person comes at a cost, right? So you're paying a DevOps engineer or a database administrator, whatever they are, a reasonably hefty salary, right? Depending on where you're based and so on. But is it worth it, right? To do all that when if you converted that into a monthly cost and then paid a managed database on a large cloud platform or from, an independent like Ivan or, one of those kind of companies, is the cost benefit analysis worth it to have it running in your own kube cluster versus on RDS?
So I would have two takes at this. First of all, we have quite a few customers that simply are not allowed due to legal reasons or due to customer demand to run an RDS. And then the other thing is that RDS simplifies a lot of things. But I have, for example, talked to some customers who, a bit like you just said, they spun up RDS. But for example, since they didn't have any database administrator among them, they only realized that they need to test disaster recovery when the disaster first hit. So in that case, they were kind of lucky, right? They just could just take the slider in RDS, do a point-in-time recovery, and phew. But that was a bit of a wake-up moment, right? I mean, the more valuable the data that you're storing, the more seriously you have to take to also have the skills around you. So at some point, it's just an investment that you need to make. And then what I noticed is that we actually hired some people that have done databases in the pre-containerized times, and they were really fascinated, like, wow, it's this automation, this operator does exactly what I was supposed to do before, but it does it now for me. And they were very excited that on one hand, they felt pretty good in control, but that also liberated them for, let's call it, higher level functions, right? They didn't have to think anymore about how do I connect the primary to secondary or how do I configure point-in-time recovery, but rather they could figure out, okay, then probably I need to check. They had perhaps more time to check if this actually works as expected, or to check the impact of a configuration variable on the security and the replication posture of the database. And so that's kind of my takeaway, right? It allowed them to do higher level functions, and perhaps with one person, then you can address more environments than what you would have been able if you had database administrators just having to babysit database clusters.
Yeah, I think when we think about developers, when we containerize a database, it does mean that the developer now can worry about their code rather than their infrastructure. That becomes the focus of their job. So that's great. I think for data professionals and DBAs, there's still a requirement there. It's a higher level discussion. They need to understand recovery point objectives, business SLAs. How will the company respond to a ransomware attack? What steps will we take if there is a bad actor in the organization? How do we cover back? What's the system in the dependencies? No application, no database lives in isolation. What's the dependencies between them? If you restore this one, do you have to restore that application? What about your SaaS solutions? So I think we start not focusing on backup scripts and cloning scripts. We focus on what is our data, where does it live, who has access to it, and we manage the data rather than the environment the data lives in. It's about making sure that only the people that need to access the data, and knowing when there is a problem, where our data is, how many copies do we have, and does that satisfy the business SLAs around that? Because do we know how long it will take to restore the system? Have we ever done it? Have we ever tested it? The analogy I like to use is, if you was a pilot, you would go to simulators regularly. You would sit in there and you would fly your plane. You would land it. You would take off. But you do more than that. You would practice different incidents, different disasters, and then when it happens, if it ever happens, you practice it before you feel comfortable. Also, they have a cockpit manual which says, in the event of a disaster, do this, turn this switch on and off. We should always have in our IT systems this idea that we don't have to think when there's a disaster. We've done it before, and it's documented. And I don't think we're probably there yet in the Kubernetes space. We've got to take some of the good hygiene we've had with traditional systems and rework that into the container world.
I think that's actually a really good answer, because even if you decided you weren't going to run any databases yourself and you just use database as a service, those are still questions you need to think about and answer. They might have the technical capabilities to do automated backups and have SLAs built into the platform and stuff. But you still have to make the business decision about well, which of these databases as a service are we going to pay for? Because which SLA do we require? And how often do we need backups? And what does that actually look like? Can we test it? All of that strategy still needs to be defined, and particularly the piece about data access, right? Someone has to manage that for a database as a service. They're not going to. Well, I suppose you could just make it publicly. You can make it one at 7. So then there'd be 700,001 databases publicly addressable on the internet. But yes, it doesn't really might solve your problems, but it doesn't make you very secure.
I guess we ought to look in the chat box, see if anything's arriving there, and we'd like to make this interactive for anyone who's online. Nothing as yet.
Nothing in there. So please do fire your questions away. If not, I will keep asking stuff, and we'll talk around there. So.
I did a presentation earlier today at conference, and it was on the topic of using running databases and containers and database as a service. And really, I was trying to say that because there's so many different database operators, when you go to market and you decide which one you're going to go, whether that be your enterprise DB or your Crunchy DB or your Bacona or ... you need to have some criteria. And that criteria can be a functional requirement and a non-functional requirement. So really, in the same way you would normally decide on infrastructure or software, and have some criteria you're going to grade it against, or what your business requirements are, we need to do the same for our operators, because they're not all the same. Some of them deliver very great topologies, maybe very advanced for high availability in DR, but maybe are weaker on the security. Maybe some do rolling upgrades and some do have to shut the database down to do an upgrade. Can you stop and start the service? If you're in the cloud, that may be really important to you, that you can stop the service so you don't pay for CPU cycles over the weekend. So I think you still need to have the same idea that just because it's a service, you need to know what you want out of that service before you make your selection.
Exactly. And Ron, you brought a very interesting topic that I'm kind of hoping that by not making database administrators focus on scripting and, let's say, plumbing things together, they can perhaps also focus more on interaction with application developers. Because even if you have a database as a service, you generally can configure them when they should be patched, right? They have a certain maintenance window, and of course they get automatically patched, so nobody has to wonder about that. But then at some point, you still need to explain to application developers, okay, please make sure that your application reconnects properly to the database, because otherwise bad things will happen, right? And then at some point, you might need to migrate from one major version to another, and that also needs to be planned and needs to be discussed with the application developers. And then hopefully, database administrators can move from a stay down in a bunker and babysit databases role into more of a customer, what would you call it, technical solution architect role towards their application developers, and really more act like the coach towards application developers to get the best out of the database. And like you said, right, somebody still needs to understand which operator to choose and which criteria. And I noticed that when coming up with criteria, it's not so difficult to fill in the checkboxes or fill in whatever criteria I chose, but rather coming up with the right criteria is the most tedious part. I had many customers that they didn't even know where to start. And then I noticed that much of the value was just in asking the right question and not so much having the right answers, right? Because it could be that one of your operators doesn't have support for what you want to, but is crazy good at something else. And that you can then just convert into, a risk that you're accepting, right? Okay, every month, say the example you just said, an operator doesn't support rolling upgrades, but imposes stop the world kind of upgrade. Well, maybe if other features are so crazy good, you might want to accept that and say, okay, once a month, we're going to have a 5 minutes click on the application. No worry, we're serving customers just during one time zone. Nobody cares about our application at midnight. We just accept that risk. And somebody needs to be good enough to understand both the database part, but also application needs to be able to steer that conversation.
Yeah, I think sometimes, well, you need to even drill it into what does the statement mean. So you look at the operator, it says performs backups. So is that backup a file system backup? Is it a storage snapshot? Is it a native backup like a RMAN or MySQL dump or PG backup REST? What technology is it using? If that backup is unique to that platform, is it still portable? Can you take it out of the cloud or into an on-premises solution? So there's lots of times when we look at a high-level data sheet, we need to actually understand the detail behind that. One of the things we do in the database world is, we often look at access logs and look at audit logs. Will you have access to those as a database as a service? Will you be able to get the metrics that you need to be able to give back to the application developers to tune the application? One of the things that I see in the database as a service model is the idea of, the database service provider upgrading the environment. May be okay with minor releases, but you do a major one, that may require application regression testing. Are the application team on board with this? Are you committing them to do regression testing once a month or once a quarter so that you can buy into that database as a service solution?
Yeah, that's interesting that you brought up audit logs. I had once a customer case in which some of the application developers had access to the production database because they needed to do, for example, ad hoc analytics, right? And it just doesn't make sense to go through the proper change management. All you need is one SQL statement, right? But on the other hand, it was a regulated industry, so they still needed to know who typed what SQL command at what point and what happened to that data. And there we noticed, for example, at that time, there was a huge gap between how AWS RDS was implementing audit logs. They were pretty much showing you just an opaque MySQL user, but it was not tracked back to the federated login that was giving access to AWS. And that was quite a long discussion, quite a lot of plumbing to make sure that, well, the needs of the customers are being met, although the database itself was managed. A bit like you said, like somebody. And then what I felt is that you don't only need to understand what's in the product sheet, but also to actually be in that organization and understand, so what are the implications? Yeah. Okay, let's say that this particular provider doesn't support audit logs. So what? What are we missing out on? What will we have to do in order to compensate for that, and so on? And it's really difficult to get that knowledge.
I think it depends very much in the industry you're working in. You may find that you have internal or external auditors, and you may have compliance teams that you have to demonstrate that you're in control of your data and you know who accessed the data when. So the ways of working which we have adopted in the last 20 years in the data center, need to be considered in the cloud and in the container space.
Mm. Yeah, Ron, you talked about choosing the right operator there, and I know that quite a lot of people end up building their own. What would you say are the pros and cons over? You kind of picked some of the examples there that maybe you find an operator that goes like 90% of what you wanted, but not quite everything. What are the pros and cons of getting to that 100%, but having to build and maintain your own operator?
I think you're right there, Ed. It's the build and maintain. Do you have the skills to do that? Are you able to keep that up to date? Can you react to a Log4j incident quick enough? If you're, if you are buying a service, someone else owns that headache and that pain. And this is actually quite, an interesting point on like open source. I always say when someone, takes a very small fork of an open source project, is that still being maintained? Has that developer moved on to something else more interesting? That's the same challenge internally. So if you developed your own system and the person that done that is now being redeployed or has left the organization, does someone else own that? So yeah,
Which,
if you can get one that is 95% off the shelf, what you want it to do, and that gap is you can negotiate it away, or you can have a workaround that satisfies the business. And I think that's the agreement, that you get agreement that it does satisfy. You don't own that component. If you're not allowed to own that decision, that you advertise it, yeah, go for something that's going to make your life easy.
Yeah, I think you're right. Like, let's be honest. How many developers are you going to have in a company who are fluent with Kubernetes and Go and writing their own operators? Right, probably one. So you're right. There's the bus number's not very big on that when that person leaves, and you're left going, oh no, how on earth do we support this thing?
Yeah, I totally second Ron's opinion. I also find myself increasingly not picking open source projects based on technical capabilities, but rather based on governance and community. Because if they are lacking a certain technical capability that we need now, maybe they have it in the future, right? That's something, quote, easy to fix, right? Whereas if the government is just bad, a bit like it's a one-person project, or on the contrary, it's a one-company project whose interests are not very clear, then although technically it might be the best choice today, you have zero guarantees that the agenda of the project won't change to the point where it kind of works against you at some point, right?
Yeah, I think that's that applies to all open source stuff. We have that a lot as a company. So we build. So we have an operator that runs, and ours deploys machine learning models. While the models themselves, I guess in theory, can be stateless, because you can spin them up and down, and there's an initializer that goes away and grabs your actual model artifact every time you spin one up. We use a lot of different open source tools under the covers. So we actually, for that method there, right, we use a tool called rclone, which supports, I mean, you guys are probably familiar with it, but yeah, it supports 40, 50 different data sources, and that for us is really easy. But we had to, so that's a really pivotal decision for us to make that, because if that disappears, we're left maintaining our own data connector that has to go and pull huge files from S3 buckets, or network file stores, or wherever else, wherever people end up storing their machine learning models, right? And sometimes these are not small files, right? They can be tens of gigabytes, right? And we need to be able to pull that in a consistent way, store it, have it all validated before we even start an inference server to be able to run predictions against it. So yeah, it's a challenge, right, that everyone has.
I think something else we ought to be mindful, and I guess it's really good when you have something that everyone can identify with. When you're like the Log4j incident came at the beginning of the year, if you were developing your own solution, you have to know where those libraries are used in your solution. You have to know what your vulnerabilities are and be on top of it all the time. If you're buying it as a service, you've subcontracted that to someone else to worry about.
Yeah.
So it's very much what skills do you have locally, and what's your appetite to be on top of it all the time.
Mm-hmm. Yeah. So something we actually were talking about before we even started, but I wanted to revisit was the kind of data locations, right? So one of obviously the big benefits of running data on Kubernetes is that you're in the same environment as your applications. Now, if I use my use case again for machine learning, often when you want to make a prediction, you might say, let's call a recommender system. Let's say, here's the user ID, go and recommend me products for this user. Well, that's not enough information for it to be able to recommend products, right? It needs tons of other information on the user. And if that means making requests out to some external provider, data lake somewhere, potentially on a different cloud, or in some other data center somewhere, that massively slows down your inference request. So from our point of view, the more people who run data workloads on Kubernetes, the better. And there's actually, I was mentioning to both Ron and Christian earlier that there's now this concept in the machine learning and MLOps world of a feature store, which is basically storing all those important hot features that you're going to need to either call at runtime, or that you want to do fast iterative machine learning work on, and inevitably, they've ended up being deployed on Kubernetes because that's where people need the data next to the actual infrastructure. But do you see this a lot with your customers? That's probably one of the big drivers for wanting to run databases and data workloads on Kubernetes.
I could add a bit on this. So one of the main drivers that I have seen why databases are running in Kubernetes is that when you need to run your application on various infrastructures, you kind of don't know what you're getting, right? I mean, there's one thing in running in a mature cloud like AWS or Azure, and there's a completely different thing on running on-prem or maybe on an edge. You might not have a private network. You might not have some DNS that you can just configure via an API. But fortunately, you kind of get these out of the box with Kubernetes. I mean, it offers, this pod in cluster networking. It offers DNS via services. So it almost replicates the benefits that you feel with big cloud providers, but, just within a Kubernetes cluster. And then afterwards, you mentioned location due to latency and due to size. What I'm noticing is that people are a lot more concerned about location of data due to privacy reasons. So imagine things like healthcare data. I'm not sure what's the atmosphere in other countries in Europe, but in Sweden, for example, if you have a US cloud company somewhere in the supply chain on which you're storing patient data, you're very quickly going to lose a contract on this topic. So then what do you do? I mean, today you might have to run it on these virtual machines. Tomorrow you might have to run it in this OpenStack cloud. The day after in this other VMware-based installation. You never know if you have a database service or not. And then how do you standardize across all these platforms? Well, Kubernetes. And then you have container orchestration, you have private network and private DNS out of the box. And it's not so much, like I said, location of data due to performance reasons, but location of data due to compliance and contractual reasons that I'm seeing as a driver for databases on Kubernetes.
Yeah, that's me with my my engineering hat on, is always just thinking about how do I make stuff easier for myself to do machine learning engineering. But you're right, of course, to a company, actually, the location is much more important.
Yeah, data sovereignty can be a big challenge. I mean, some of the cloud providers do have like governmental cloud offerings to help with data sovereignty and some of the EU requirements about data, HR data not leaving sort of country boundaries. Another thing, I guess, we have to think about, and you mentioned about, it's not just the technology; there's also the cost. We have to consider, the inter-cloud costs, the inter-region costs, so the egress costs. They can be significant. So you need all your data in every location, in every geography. So do you want to replicate it, and do you want to pay for that replication? So you have to understand the value of that data and the importance of it being, if you can replicate it, do you want to pay for that? If you're going to do a restore, how much is that going to cost you? How long is it going to take? Even though networks have improved, there's still latency. If you've got a large data set in your own data center and your machine learning is in the cloud, or your database in the cloud, it's going to do external tables, it's going to take a long time to get that data. So edge processing, I think, is something where we're going to see containers taken off in the next 5 years, where we have lots of IoT and sensor data being collected locally, processed locally, and then maybe the summarized version being sent to a data lake or data warehouse for further analysis or long-term archiving and that deep learning we talk about.
Mm-hmm. Yeah, what do you see as being the best way to? Because actually, that I'm starting to see that already. Maybe not massively in production, but we had a really interesting open source user of ours write a really good blog about how they're doing machine learning inference on the edge using Raspberry Pis and K3s and they use our Seldon Core library on top. But once you start to deploy those out at scale. Let's say they install an operator alongside it that has, a Postgres database or something, just for the request logging. What are some best practices for managing that, right? When you're managing multiple, potentially thousands of kube clusters, all with their own operator on them.
It's going to be a challenge. You don't think
maybe they don't exist yet.
Well, right? You have to consider the challenge. If you were an international supermarket and every one of your branches had local data being generated, point of sale information, warehouse information, every single one of those can be its own little data center.
Mm-hmm.
And you may want to process that locally. But some of the stuff has to be some of the sales or stock movements has to be managed centrally. So you have to replicate that up. So it's knowing what data you can process locally, what you can replicate, and can you manage it securely in these different environments? If it's just a cupboard somewhere with some Raspberry Pis in there, is it secure? Can someone just come in there and take ownership of your network? So there's lots of challenges, I think, from a physical security, network security, and an application data security when we think about edge processing. So we've made it a lot harder, but we also got better tools with VPNs and ways of working, which we've matured over the last 10 years.
I was actually wondering, Ed, when you asked about edge cases, because I heard people using K3S like in two different contexts. The one of them where, let's put it, you still have SSH access to a node, so you still get some kind of access, maybe a KVM either or something like that if things go wrong. But then I also heard people that are as daring as to use Kubernetes in like real IoT applications where basically you don't have access to a node anymore. And then you have to spend significant amount of time of, okay, how do I push updates there in a very, very safe way, because I won't have a second chance if this update goes wrong. And then how do I create then the close the loop where I bring monitoring data back in order to convince myself that all those 1,000 clusters are actually running as I would like to? And no, you cannot kube control against it, or you cannot SSH against it. You just have to build around it so much more in order to convince yourself of all of these.
I think what we'll end up with is some hybrid of what we've done with operating systems and embedded operating systems, where we've got like micro kernels that just do a very small thing but do it very well. And I guess that's what we see with K3. It's it's tuned. I think when we start processing on the edge, maybe more of an appliance model. Maybe it doesn't have to have the full network experience externally because you want to lock it down, you want to process it locally. Then you worry about data persistence. What happens if you've got data there? How can you secure it?
I mean, if you think about it, some of these workloads are you're not even going to be able to close that loop. It might be out in a gas field somewhere on an IoT device, and it literally the way you go and collect the logs from that and the data is to go send an engineer out who goes and collects the SD card.
Yeah,
like that might be, and they might flash the update onto the thing. That might be the only way that you do it, right? Which suddenly makes it totally different management experience. Right?
I think we have that. I think we have that with some of our submarines that go around the world. They only send home data when they get back to port, or ships. They're completely dark, off the grid. I think every organisation has different data handling challenges.
Yeah. Cool. So we've only got a couple of minutes left. I still haven't seen any questions popping up in the chat or the Q&A.
Well, thank you for the 62 plus people that have stayed with us for this last 40 minutes. I hope you've.
Yeah, I hope we've been rambling in the right trajectory and it's all been relevant to you.
Sounds a bit more like a podcast, doesn't it? It's sort of like that sort of interaction. It's been quite natural.
In case you don't store data on Kubernetes, I hope that we at least informed you or amused you, depending on what you're looking for.
Yeah, I don't know if Christian or Ron, if you have anything to add before we wrap up.
And I guess my closing statement would be it's a very exciting space to be involved with data. It's for people that have been used to managing data for many years. We think we've done it all. We think that's it. We create data, we back it up, we restore it, and we clone it. It's the Kubernetes world has given us new, fresh challenges about the way we operate, and also the expectations of developers. I think that's what's changed. Is I've been in a world where I did releases every 18 months, and then maybe every refreshing environments every 6 months, 3 months. Now weekly releases, daily releases, environments being refreshed daily, or some people create environments multiple times every hour or even quicker. There's lots of different challenges. So anyone that's coming into the IT industry now, you're in for an exciting ride.
Yeah, I'd add to that you're also, on top of doing some really interesting stuff, you're going to be learning a ton of really transferable skills. So even if you're managing data workloads on Kubernetes, it's easier than ever to move across to doing traditional application DevOps or even machine learning roles, right? Because now more and more data scientists are trying to deploy stuff on Kube, and we're using tools like operators and managing data in that way. And I just think everyone is like desperate to get their hands on anyone who's got experience with operators and Kubernetes.
I think we're in the 10-second countdown, so Christian, to bring it home.
Just one more thought I want to say to all the audience there. So I'm really excited to see how Kubernetes is standardizing things and is making tedious and boring stuff that much more tedious and boring. And it liberates us stuff to do time and brain power to do more complicated things. And I'm really excited to see what that will bring us.
Great. Christian, Ron, thank you so much for joining us. I was Ed, and I hope you enjoy the rest of the conference. You can reach out to us on the platform if you have any other questions, and we'll see you around.
Thank you.
Thank you so much.
Bye-bye.
Bye.